This video is for 8th grade accelerated math, lesson 13.5. Please note that originally most of this video was made for secondary 1 math for a different numbered lesson.
All right, today we're going to talk about factoring trinomials. Again, we've already learned how to factor doing the GCF. This time we're going to do it a different way. And remember that factor means to undo the multiplication. Okay, so if we were to multiply this out, let's go forwards first, then we'll go backwards. We would do x times x, which is x squared, x times 5, which is 5x, negative 2 times x, which is negative 2x, and then negative 2 times 5, which is negative 10. We would see that we have like terms right here, so my answer would be x squared plus 3x subtract 10. So how can I go backwards? How can I go from x squared plus 3x minus 10 back to what I started with, which was x minus 2 times x plus 5. So I'm trying to figure out how can I go from here to here. Well, first of all, when we're factoring, we're always going to ask the following question. Is there a GCF? That's the first thing we want to do every time. Is there a GCF? If my answer is yes, then I'm going to factor it out like I did in lesson 11-4. If my answer is no, then we're going to factor into two binomials, just like we saw on the previous page. So where I'd have like x minus 2 times x plus 5. That would be two binomials. Okay, so if I have x squared plus 3x minus 10, let's go ahead and read this question here. When factoring a trinomial with a leading coefficient of 1, all that means is that this right here has a 1. That's a leading coefficient of 1. Into two binomials, ask the following question. What are the two numbers that when added together equal 3 and when multiplied equal negative 10? So what are the two numbers that when added together give me this 3 and when multiplied give me the negative 10? We're going to use something called X games to help us do this process. So factor each polynomial. The first thing I want to do is I want to ask myself those following questions. Number 1, is there a GCF? As I look through here, I can see that I have x plus 3x plus 2. There is no GCF, so my answer would be no. Since my answer is no, what are the two numbers? So we're going to fill in this blank here. Go ahead and add that. What two numbers, when added together, equal, I'm looking for 3, and when multiplied, equal 2. So what two numbers can you think of that when added together equal 3 and when multiplied equal 2? And hopefully you already know the answer. We're going to use what we call X games to figure out the answer. First of all, up here is where we put the number, the middle term. That's where we're looking for whether it's adding or not. And then the last term goes down here, and this is the one that's multiplied down here on the bottom of the X. So my first term the middle term was 3, and my last term, the third term, was 2. So what two numbers, when multiplied, give me 2, and when added, give me 3, but hopefully you know the answer is 1 and 2. So 1 plus 2 equals 3, and 1 times 2 equals 2. So my answer is x plus 1 and x plus 2. We could also write that as x plus 2 times x plus 1. It doesn't matter the order. Okay, let's do some more of these. Okay, here's number 2. Go ahead and write it down. It's x squared plus x subtract 30. We are looking for, first of all, is there a GCF? No. So we are looking for two numbers that when multiplied, I'm going to go ahead and draw my x games over here, that when multiplied give me negative 30, and when added give me a positive 1. So I want to look at all my options here for factors of negative 30 when I multiply them. I've got 1 and negative 30, 2 and negative 15, 3 and negative 10, and 5 and negative 6. Now if I multiply all these together, they're going to equal negative 30. But do any of these added together equal positive 1? Well, 1 minus 30 equals a negative 29. 2 minus 15 is a negative 13. The next one's negative 7. And this one's a negative 1. But I could see that if I change this 5 to a negative and the 6 to a positive, then that would give me a positive 1. So my two numbers are negative 5 and a positive 6. So negative 5 plus 6 equals 1, and negative 5 times 6 is negative 30. So my answer is x minus 5 and x plus 6. Number 3 is m squared subtract 9m plus 20. I'm looking for two numbers that when multiplied give me 20 and when added give me a negative 9. So think of two numbers that when multiplied give you a positive 20 and when added give you a negative 9. Hopefully you were able to figure out that that is negative 5 and negative 4. Negative 5 plus a negative 4 is a negative 9. Negative 5 times a negative 4 is a positive 20. So my answer is m subtract 5 times m subtract 4. And the way to know if I did this right, what I would do is I'd go ahead and distribute this back through. I just multiply it back out. M times m is m squared. M times negative 4 is negative 4m. Negative 5 times m is negative 5m. And negative 5 times negative 4 is a positive 20. And here I have like terms, negative 4m minus 5m, which gives me my negative 9m. Number 4 is p squared plus 3p subtract 40. Okay, once again, I'm going to do X games, and I'm looking for two numbers that when added give me a positive 3. That is just not wanting to make an add there. There we go. Added give me a positive 3, and when multiplied give me a negative 40. This one might be a little trickier. If you're having a hard time figuring out, start writing down the factors of 40. 1 and 40, 2 and 20, 4 and 10, 5 and 8. Are any of those 3 apart? Well, that's our 5 and 8. But one of them has to be negative because I'm looking for a 3 and a negative 40. So which two numbers, if this is a positive 3, I know that this has to be a negative 5 because negative 5 plus a positive 8 would give me a positive 3. So my answer is X, oh, it's a P, P subtract 5 times P plus 8. If you wrote it as P plus 8 times P subtract 5, does not matter. Same answer. So either one of those would be correct. Okay, number 5, c squared subtract 6c subtract 40. And I'm going to give you guys about 30 seconds to figure it out on your own. See if you can do this one by yourself. All right, let's see how you did. Two numbers that when added give you a negative 6 and when multiplied give you a negative 40. That is going to be 4 and negative 10. 4 plus a negative 10 is a negative 6. 4 times negative 10 is a negative 40. So my answer, c subtract 10 times c plus 4. Or I could go the other way, c plus 4 and c subtract 10. Either answer would be correct. Okay, I'm going to give you both 6 and 7 now. Number 6 is going to be w squared minus 9w subtract 22. And number 7 is going to be n squared plus n subtract 12. Try both of those. I'm going to give you a minute, and then we'll go through the answer. Okay, let's go through each one. Go ahead and erase number 7 first so we can go through number 6. What two numbers, when multiplied, gives me a negative 22, and when added, gives me a negative 9? Well, that is going to be negative 11 and 2. So I have w minus 11 times w plus 2. Negative 11 plus 2 gives me a negative 9, and negative 11 times 2 gives me a negative 22. Okay, number 7, we have n squared plus n subtract 12. And once again, two numbers that when multiplied give me a negative 12, and when added give me a positive 1. That would be n plus 4 times n subtract 3. Or I could say n subtract 3 times n plus 4. Does not matter either way. They're both correct. Okay, now we're going to go ahead and we're going to use either X games or factoring, X games with a GCF to the rest of these problems. So what this is going to do is require you now to use both methods that we've learned and decide which one you need to do. So let's start with number 8. Number 8 is z squared plus 6z plus 8. The first thing I need to decide is there a GCF? Well, I have z times z plus 2 times 3z plus 2 times 2 times 2. And I can see that none of the terms, this is a term, this is a term, this is a term, none of them have anything in common. So there is no GCF. So the answer to that is no. If I say no, that there is no GCF, then I'm going to use my X games. So now I'm looking for two numbers that when added give me 6 and when multiplied give me 8. Two numbers that when added give me 6 and multiplied equals 8. Hopefully you saw that that is 2 and 4. So my answer here is z plus 2 times z plus 4. Okay, number 9. Number 9, we have 6y squared plus 3y. First question I ask myself is there a GCF? I have 2 times 3y plus 3y. Well, I can see that they both have, each term has a 3y, so yes, there's a GCF. If the answer is yes, then you take it out. So it's 3y times, what's left inside? A 2 and a y plus 1. There's my answer. So number 9 was just like what we did on homework 11-4 and on the warm-up today. Okay, we're almost done. I think we have 6 problems left. Number 10. R squared minus 4r plus 4. So first of all, decide, is there a GCF? If the answer is yes, you take it out. If the answer is no, you do X games. Okay, here's number 11. 3k squared minus 24k plus, I'm trying to see what that says there, 45. Okay, I'm going to go ahead and give you number 12 as well. Number 12 is 8h to the third power minus 12h plus 20. I'll give you about 1 more minute to finish up 11 and 12. Okay, let's go over number 10. Go ahead and erase these here. Okay, so first of all, is there a GCF? So if I write it out, I have r times r minus 2 times 2 times r plus 2 times 2. So I can see there's no GCF because they don't have anything in common. So we're going to erase that. So that means I'm going to use X game. So I'm looking for two numbers that when added together give me negative 4 and when multiplied give me a positive 4. Hopefully you saw that that was a negative 2 and a negative 2. So it's r subtract 2 times r subtract 2, or you could write this as r subtract 2, the whole thing squared. So either way, you could write that answer. Okay, our next one, number 11, was 3k squared minus 24k plus 45. First thing I want to do is see if I have a GCF. So I have 3k minus 2 times 2 times 2 times 3k plus 3 times 3 times 5. And I can see they each have a 3. So my 3 is my GCF, so I'm left with k squared minus 8k plus 15. But I'm actually not done, because then I'll notice that right here I have a leading coefficient of 1 and a trinomial. So let's see if I can use X games now to factor what's inside here. So I'm looking for two numbers that when added give me negative 8 and when multiplied give me 15. Well, that is a negative 3 and a negative 5. So my final answer here is actually going to be 3 parenthesis k subtract 3 times k subtract 5. And that's my final answer. All right, let's finish up our last four problems here. So we have number 12, which was 8h to the third minus 12h plus 20. Is there a GCF? Let's see. 2 times 2 times 2, h minus 2 times 2 times 3, h plus 2 times 2 times 5. Well, I can see they all have a 2 in common. So I'm going to have a 4 on the outside with a 2h to the third minus 3h plus 5. I know at this point I'm done because this trinomial right here has a leading coefficient of 2. And in order to factor that again, we're only doing leading coefficients of 1. So if you have a trinomial with leading coefficient of 2 and it's not a squared like that, that's a cube, so we know we're not going to go any further. That's as far as we're going to go. Okay, so let me go ahead and write that answer down again so it looks a little bit nicer. So 4 parenthesis 2h to the third minus 3h plus 5. That's our answer to number 12.
You should now pause the video and work on 13, 14, and 15 on your own, and then come back and see how you did.
The first thing I need to determine is whether or not there is a GCF. Let's write it all out. M minus 2 times 5m minus 2 times 2 times 2 times 3. And we can clearly see there's not a GCF there. Let's go ahead and erase that. So we're going to use X games to determine what two numbers, when added together, give me a negative 10, and when multiplied, give me a negative 24. Hopefully you determined that that was negative 12 and 2. So my answer number 13 is m subtract 12 times m plus 2, or you could say m plus 2 times m subtract 12. And we can see that negative 12 times 2 is a negative 10. Negative 12 times 2 is a negative 24. Number 14, 10a plus 17. First thing I need to do is determine whether or not there's a GCF. 2 times 5a plus 17. There's not a GCF. Neither is there a squared here or trinomial. So our answer here is cannot be factored. Okay, last problem. We have g to the power of 3 minus 8g squared plus 5g. First of all, is there a GCF? We have 3g's minus 2 times 2 times 2 with 2g's plus a 5 and a g. Sorry about that, I have a tickle in my throat. I can see that I have a g in common for each one. So my GCF is g, so that's going to go on the outside. Then I have g squared minus 8g plus 5. Now, if you'll notice, I do have a GCF of 1 here, so I could see if I could factor just this part again. So I'm wondering, are there two numbers that when multiplied give me a 5 and when added negative 8? And it turns out there are not, so this actually cannot be factored any further. So the final answer for 15 is g parenthesis g squared minus 8g plus 5.
For the rest of this lesson, the numbers of the problems will be different, but the problems themselves will be the same, so just follow along with the appropriate problem.
Okay, number 11, this time we're going backwards. This time I've given you the area, and you have to be able to find the dimensions. And you're probably wondering, how are you going to do this if I didn't give you either one of them? Well, let's look at what we have here. We have y squared plus 13y plus 30. And if I look at this type of problem, I can tell I do not have a GCF. If I write this out, I have y, I need to pick a color here, y times y plus 13y plus 2 times 3 times 5. So there's not a GCF, and we know from our last two lessons that if we do not have a GCF, then we need to use X games. So let's go ahead and use our X games here. So I'm looking for two numbers that when added together give me 13, and when multiplied give me 30. So if I look at the factors of 30, I have 1 times 30, 2 times 15, and 3 times 10. I also have 5 times 6. Well, we can see that 3 times 10 is 30, and 3 plus 10 is also 13. So I know my two numbers are 3 and 10. So that means that this is going to be y plus 10 meters, and our height is going to be y plus 3 meters. Okay, let's go on to number 12. Okay, once again, on this problem right here, we want to find the dimensions. And remember, for a triangle, its area equals 1/2 base times height. So if I want to go backwards, I first of all need to look at how I went forward. So 1/2 of the base times the height. Well, that means half of something equals this. So to go backwards, I need to multiply this by 2 to begin with. So I have 2 times 8m to the third power, subtract 4m. That gives me 16m to the third power, subtract 8m. Okay, now I need to look at it, and we're going to factor it. And first I need to ask is there a GCF? And yes, there is. We're going to go ahead and write everything out. We have 2 times 2 times 2 times 2, m, minus 2 times 2 times 2, m. Okay, we're going to circle what they have in common. They have 3 2's and an m. And here we have 3 2's and an m. So outside my GCF is 8m. And left inside is 2m squared, subtract 1. Now we're looking for the dimensions here. So I'm going to go ahead and write this down a different way. We don't know really which one goes where. I'd have to pick a number and plug it in to find out which one's bigger and which one's smaller. So it doesn't really matter. So what we're going to do is we're just going to go ahead and just write them separately. So I know that one side is, here we go, 8m inches. And our other side, if I erase this, is going to be 2m squared minus 1 inches. So this is one of the sides, and this is the other side. Okay, I'm going to walk you through that one more time, but we're going to go really fast. Okay, so for those who are still kind of going, what just happened there? Because I'm sure there's a few of you. Okay, so once again, what we're going to do is we're going backwards. So to go forwards, I have to multiply by 1/2. So to go backwards, I'm going to multiply by 2. So 2 times 8m to the third power, subtract 4m. So I have 16m to the third power, subtract 8m. Now I'm going to go backwards. I'm going to factor this, and I can see there's a GCF. So I'm going to break it down. 16 is 2 times 2 times 2 times 2m. Subtract 8m, which is 2 times 2 times 2m. And I can see that they have 3 2's and an m in common here, and 3 2's and an m in common here. And I just realized that I forgot my other 2 m's in this one. So I'll just put those out front here so I can see I've got those left over. Get them out of there. Okay, so on the outside I have 8m, and left on the inside I have 2m squared, subtract 1. So all I did was I took this one and said I've got 8m inches. That's one of my sides. Then I took the other one and I said I have 2m squared, subtract 1 inches. So those are my base and my height. And it doesn't matter which one you say is which. We're just finding them. Okay, on number 13, we obviously have a square here because we have the markings that show that all 4 sides have the same length and all 4 angles are 90 degrees. So we have a square, which means that we know that all 4 sides are the same. So we're going to go ahead and find the base and the height, and we have our area right there. And we're first of all going to look at it and say, do I have a GCF? And we're going to say no, so we're going to use X games. So I'm going to go ahead and give you guys a minute to see if you can figure that out. Okay, in the X Games we have plus 8 and multiply 16. So two numbers that when added together give me 8 and multiplied give me 16. And that is 4 and 4. So I know that we have x plus 4 times x plus 4. So what's one of the sides? Well, my answer would be x plus 4. And we're going to put feet here. So we know that each side, since it's a square, is x plus 4 feet. Okay, problem 14. Once again, we are going to go ahead and factor this. This one's a little bit harder though because I've got the 1/2 base times height. And remember, to go forwards I multiply 1/2, so to go backwards I multiply by 2. But if I multiply that by 2, then I have a leading coefficient of 2, and we only know how to factor things with the leading coefficient of 1. So we're going to wait till the end to multiply by 2. We're going to kind of hold off on that for a minute. Let's go ahead and look at this problem though. We know that we have this trinomial right there, and we do not have a GCF, which means that we are going to be using X Games. So go ahead and factor that using X Games. Give everybody about a minute or about 20 seconds to do that. Should go pretty fast. Okay, so what we're doing is we are looking for two numbers that when added together give us 10 and when multiplied give us 24. And we should know that that is 6 and 4. So we have W plus 6 times W plus 4. But remember, we're multiplying the whole thing by 2. So we have two possible answers here. So we can distribute the 2 through the first one here and get 2W plus 12. And that would be our yards, which means our other one would be W plus 4 yards. So that's one possible answer for our base and our height. Or we could multiply the 2 through this one right there, which means we would have W plus 6 yards for our base or our height, and 2W plus 8 yards. So either way would work for this problem right there.